We are in AP Precalculus. We're doing the notes for topic 1.4, polynomial functions and rates of change. And it has this maybe helpful definition of polynomial functions. It's a function. A polynomial function is any function representation equivalent to this form where you have some number out in front and some power. And then that other number and the power goes down by 1. Another number and the power goes down by 2. Another number, and eventually it ends up with no x term. It goes x to the power of 2, x to the power of 1, x to the power of 0, which means there is no x term. That's a general description of polynomial. Okay, I don't know what we can do with that yet, but maybe it'll be helpful later. It tells us that n is a positive integer, ai is a real number, like all these numbers out front are real numbers. Well, ai is a subscript I. So a subscript n is a number, a subscript n minus 1 is a real number like 2 or -7 or something like that, right? Or artificial intelligence, depending on what we're talking about. So if this is the polynomial, what is the leading term?
A.
It's this terms are separated by pluses or minuses. So what's the first one?
A subscript n x n.
Write it down, yeah. A subscript n and then x to the power of n. That is the first term. We call that the leading term. All right, the degree, another way of saying the degree, so the leading term is just who's first. The degree is the highest power.
So the square 2.
Well, I bet this number over here is even bigger than 2. That number right there is the degree. The degree in this one is n. It's usually the number out front. If you're writing these in standard form, then you should have the highest power out front, so it should be the power of that first term. Ooh, this is not a leading term, it's a leading coefficient. Coefficient is the number in front of the x or in front of the variable. What is the coefficient? The leading coefficient? A sub n. A sub n. Now you know your definitions of what is degree. It's the highest power. Leading coefficient is the coefficient in front. Leading term is the entire term in front. So far, so good with our vocab. We all nod our head, yes. All right, cool. Example number 1, find the leading coefficient and degree of the following polynomial functions. Oh, this goes easy. All right, what do you guys got? Leading coefficient of A.
3x
to the power 4, easy peasy. And what is the degree, Josue? Well, it's whatever power you were at. The biggest power that you see there is? Power 4, yeah. So that is the highest power, so we just say that is the degree of that polynomial. All right, Anatoly, you're doing B, Saul, you're doing C for the video. Leading coefficient for B, Anatoly?
11.
I tricked you. This is not in standard form.
Oh yeah, and then it's -7 next to the third.
So it always has to be the biggest one. So this entire thing should have been first. So the leading coefficient, say one more time, is?
-7 next to third.
Oh, careful. Did I say coefficient or did I say term?
Oh my god.
Coefficient.
Coefficient. So I'm just looking for that first number out in front of the variable.
Wait, but
Why'd
what's
you
first?
put?
Ah, dang it.
I'm so
Y'all can log the
slow
extra
at
credits.
that.
Yeah, it should have been 3. I don't know.
What's
I
the name
saw
of
it
the
first.
7?
Today's the 7th. The 7th of November.
7-11? Or 11?
11/7.
Yeah, it is the 7th of November.
Yeah,
Right.
so it's 7-11, yeah.
Sure, yeah. Actually, the degree of that polynomial, therefore, is 3. All right, you guys caught me. And let's give this a solve. Leading coefficient. 4. Oh, so easy. How did you get that? And then, the degree. This one's a little bit tricky.
One.
If it was 4x, then the x would be to the power of 1. There's not even an x. So it's really x to the power of 0. Anything
I
that's
said
x to the power of 0
0.
is 1, which means it doesn't exist. And yeah,
I said 0 and then I said 1.
it is a degree of 0. Ha, trick you. Okay.
I
What are you
was
doing?
gonna say that. You changed it too quick. I want to mark that too.
No. All right. The extrema of a graph are the minimums and maximums of a function. There are how many types of extrema? There's either the really up one or the really down one.
Wait, hold on.
Extreme?
Would you go up just like a little bit?
No,
Okay,
absolute.
that's one.
Okay, I mean that is a good technically there's an absolute max and then a relative max, an absolute min and a relative min. So maybe the true answer is 4 here. You're being pedantic. I'm just gonna say there's 2. There's a max and there's a min. Or you can say there's local versus there's global. Or there's relative and there's absolute. I think that's what it's probably trying to ask.
Okay. There's a high chain of motion.
Anyway, two types of extrema. We have the relative extrema. And again, I'm just going to read here for you guys because I have a beautiful voice. A polynomial has a relative minimum or relative maximum where it switches between decreasing and increasing, or at an endpoint if the polynomial has a restricted domain. Restricted domain usually has a point and not an arrow. In the past, we've been kind of lazy about that. And I have this rule for us. In general, if you do not see an arrow, assume the function ends there. If you see an arrow, then you can assume it goes to infinity. Otherwise, we assume it ends there. Because sometimes they make this way too tiny, can't even
Did
see
you
it.
not say the opposite?
I might have said the opposite at one point. I'm looking at all the Bryan and Passwater's answer keys, and he assumes the opposite. This is, let's go ahead and find these. Local minimums are where? Well, we have, okay, so right here at 0, at x is equal to 0, we have a minimum. We also have a minimum somewhere else. -4. How'd you get -4 solve?
Isn't that another? It's low.
Yeah, I mean, it's low. If you end somewhere, that can be a possible extrema, right? So right here, and then local maximums, where? Someone's type of solve.
-2.
Okay. I'm not talking.
You can do the other one.
No, I'm good.
-2, Angela, give me the other one.
3.
-2, 3. Easy peasy. All right, that means so Sway has to do all of this next one.
What?
No, he hasn't participated. He has to do at least the first one. Okay, so hold on. Let me read the definition. So these are the absolute extremum. So the global, no matter what, it is the one to rule them all. There's only one king, only one queen, right? Of all the local maxima, the greatest is called the absolute maximum. The least of all the minima is called the absolute minimum. All right, so this way, what is the absolute maximum of this graph at x equals, or you can tell me the height and tell me where it happens.
Did you do the height too?
This one is asking for the height, yeah.
Oh, 2 and 3.
Absolute height is at
2.
2, and then, yeah, that's at x equals 3. You're ahead of me, good job. Yeah, so it happened here at x coordinate 3, and this height up here was a height of 2, so that's where the.
I can do the next two.
Okay, Claire, do the next two. Let's see what we got.
-3 and 4.
All right.
That's actually -4, not +4.
-3 and 4.
-4.
Negative,
right?
it's -4, yeah. That's actually great.
-3 and -4. It's
I did not say. I wrote down what a student told me to write it down.
No,
That is
you
not
said-
extra credit.
it
That is a
said
student
-4
mistake.
though. Oh yeah.
Okay. The absolute minimum is -3. I'm looking at the answer key, and everything is correct up until here. The answer key is telling me there is no absolute minimum, but I mean that's an absolute minimum.
Well, there's an arrow.
What did they do? A little dip thingy?
I don't know. I mean, to me, it makes sense that -3 is the lowest height down there, and it happens at the x coordinate
What
of
does it say? it
-4.
is?
It says nothing. There is no absolute minimum. That doesn't make sense to me. I'm just going to go ahead and ignore that. And if I change my mind later, then I'll come back and maybe re-record a video. All right. Moving on to example 2. All right. Find and classify each type of extrema for the functions below, or you can write n/a if there is not anything. All right. So what is the relative minimum?
There isn't one. Because there's just arrows.
There is.
I thought those were points, and then I was going to be like, you're wrong, but they're arrows, so you're right. Ugh.
Don't even mess with it.
I know, Saul's on it. Okay, so there aren't any, this was restricted in the domain, then we could have said yes there, okay. But there is a maximum, right, Saul? Where's the max? The relative
Are
max?
you
is that-
doing X or
There's an absolute
It's,
max.
it's 1.
Yeah, so it's at the x coordinate, at x coordinate 1.
Wait, it's relative or absolute?
Both. I mean, this
Because there's
height
no
is
point.
both a relative and it's an absolute. So where is the absolute minimum? Well, we didn't even have any pool of relative minimums to choose from. So nothing for that one. And because we only had one relative maximum, that is also the absolute maximum. It's very easy to choose it. That was at x equals 1. What was the height? 3, 4. And I was being a little bit sexy there. I said him. It could have been a her. I don't know. All right.
Could have been.
What about B? Angela, you do B for us.
Sure. So relative minimum is going to be at -2.
Yep.
And then relative max is going to be 3. Have
3. Is there anything else?
Yeah, absolute. Yeah, sure. Absolute minimum. So,
Oh, hold on. Are there any more relative minimum or relative maximums?
oh yeah, it's -4 also.
-4 because we restricted the domain, so also at -4.
Yeah, so then absolute minimum is going to be -2, or
And x equals -2, and the height there is
the height there is -3.
3.
And so yeah, and then absolute maximum is going to be at 2 with next equals 4.
Maximum, yep, 2, that's when we're at the,
Could -4 be absolute minimum too, or relative minimum also?
could -4, say that one more time?
Could -4 also be relative minimum?
Relative minimum, no, because if this went up, then it would be relative minimum, if this went down, it's
Okay.
relative max. Although, if I had a point out here that's went straight forever, it's both a relative minimum and a relative maximum, so it can't be both.
I mean, it just doesn't like it's a relative minimum.
Yeah. Let's go to part C, relative minimum. Who wants to do this one?
So that's good. Yeah.
Simon knows.
Okay, go.
-3 and 3.
-3 and +3, good. So high, here we go.
And then for maximum -4, 0, and 5.
Very nice. Absolute min,
-3 and 3. -3,
-3, I got
and then 4 and 5.
at the height of 4, and that happens at 5. Very nice. Again, Nancy is saying weird things, saying that over here there
Yeah,
is no
no.
minimum.
I wonder if on the AP test.
Oh.
Because it's an arrow.
Because of the arrow.
Because it goes down.
This technically goes down forever and ever, so there isn't any absolute minimum, but there was a relative. That's
That's a mistake. Right?
That's
It's
what I
pretty much
said.
the same
That's
thing as
extra
A.
credit,
Because
Extra
the
credit.
arrow-
Yeah, extra credit.
I'll give it to you guys.
Oh, okay. I'll take.
So that makes sense up here. Why? Yeah. So there wasn't any absolute minimum because this went down forever and ever. Did that change us back over here? Ah ha ha! Look at this. We found the culprit.
I knew it. I just didn't say it. I like.
Why
suck.
didn't you say it?
I don't remember.
That also
The answer is correct. We just weren't being smart. This goes down forever and ever and ever. We assume it continues going down forever and ever and ever. So is there any absolute minimum?
No.
It goes on forever.
Extra credit.
That's what I was gonna
You
say.
guys didn't find that one. I found that one.
They said they found it. They just didn't say it out loud.
Yeah, I did.
Well, you should have to say it out loud from now on. We already talked about this.
What?
You gotta say it out loud.
I said it.
You can't be like Isaac
you don't
Newton
give
and
us enough
just
time to say it out
discover a brand new field of math and not tell anyone. All right. What do we got here? Fun facts about these polynomials. Here's some fun stuff, maybe. Between two real zeros of a polynomial, there must be at least one
loud. Relative maximum.
Relative.
relative max
I got that right.
or a relative
Man.
easy peasy and lemon squeezy. Good job, guys. Polynomials that are even degree must either have a absolute
Yeah.
max or an absolute min. Very nice. Yep. And that makes sense, right? So if I have some sort of x squared function, it looks like a U shape. And look, you have to have an absolute minimum. No matter what, if you have an even degree, it's going to have some sort of shape that looks like this. If I have two real zeros, that just means it. So again, what does this mean? Let's see if you guys, I was about to say it, but two real zeros. Tell me what that means.
Mm-hmm.
Yes, what does that mean? What is a zero?
You have a 0 on the x and a 0 on the y.
Yes, it's an x-intercept. Very good. So
And you have-
if you
you have
have
one on
two
the
x-intercepts,
Wait, 2x? I thought you meant like 2, 1 on x. Oh yeah.
if you have two x-intercepts, you have to do something that looks like this, right? 1, 2, and therefore, if I have two x-intercepts, oh, check this out. That is a local max.
Why
I'm
can't
gonna
you
make
have
it
two y-intercepts?
two y-intercepts and you're not a function. If I have two
I
y-intercepts, it
guess
goes like
so.
that, then it doesn't pass the vertical line test. For now.
Oh
Right.
boy.
Yeah, again, we'll mess with that a little later. Moving on. Points of inflection. Oh boy, some reading. I enjoy reading. If someone wants to read this,
Nope, you good.
I'm good. I have a beautiful voice sometimes.
Yep.
A point of inflection occurs. Inflection occurs when a function changes from concave up to concave down. We didn't know that.
Oh.
Or from concave down to concave up. All right. At a point of inflection, the rate of change of a function changes from increasing to decreasing. Because again, we swap out the words. Do this in your notes. Write this down. I want to see your pencils or pens changing. Rate of change, we change that for slope. The definition of slope increasing is concave up. The definition of slope decreasing is concave down. So all of that makes sense so far. Good. Example 3. The graph is up there, yeah, sure. Use the graph G to answer the following. Find any values of x where G has an inflection point. All right, we have to figure out where do we change concavities here. You guys see any?
I see one.
-2, well, -2, it's concave up and concave up. It doesn't change
It's
concavities.
negative
Oh.
1, 1, and then 1, negative 1.
Yeah.
So -1
Negative
and 1, and that's it.
Mm-hmm. No.
Yeah.
So we were concave up there,
-3,
then I switched to
3.
concave down and concave
No,
up.
never mind, never mind.
There were 3 different concavities, therefore 2 inflection points, 2 dividers between those concavities.
-3 and 3
Oh,
aren't,
no.
right?
No.
Because I just keep going. That's just part of the same
It's
thing.
concave up. on
It keeps
both.
going concave up,
Yeah.
keeps going concave up, yeah. Everything over there is concave up, everything in there is concave down, everything there is concave up. So we'll say that the x coordinates that are equal to -1, 1, and, no, that's it. Just -1, 1.
And 1.
Yeah,
Oh.
-1, 1. Part B. For each of the following intervals, determine if the rate of change of G is increasing or decreasing. Okay, wait. Rate of change, cross it off. You literally do this. I
did
want
that
you to
already.
write this in your notes. I'm in charge of the notes, you can be in charge of the homework. You have to change it out for the word slope. Determine if slope is increasing. Oh, slope increasing, what does that mean? That's the definition of
Concave up,
concave up. Oh, slope decreasing, that's the definition of
concave down.
concave down. You write that in your notes because I wrote it down. Oh, and look at this, we got to explain our reasoning for each answer using features of the graph. We can't just be like, yeah,
Are
right
you
there.
for real?
I'm for real. All right, so let's go ahead and look at this interval 3 to 4. Between 3 and 4, what's going on? Between 3 to 4, what's going on?
It's increasing.
I don't even see.
What is increasing? The height is increasing, the slope is increasing, the concavity is increasing. There's so many it's that you could be talking about.
Well, concave, it's going up too, so.
So, I mean, it's concave up. I mean, so it's up, right?
The function
But-
is increasing.
You have to put reasoning?
Yeah.
That's so
That's what
dumb.
I said.
Slope.
For real?
No, I'm just gonna say slope increasing.
Increasing. And here, you know what I'm saying? You see what I got here? Look at this. Look at this. Because concave up.
Oh, that's awesome.
Oh, you didn't even see that coming. All right.
What
What about 2? Between -4 and -3.
Decreasing.
What is
It's
decreasing?
Concave down, the slope.
The slope is decreasing.
No, it's good.
Why? Because concave down. Wait, what?
It's concave up, hold on.
Wait a second.
¿Qué pasa?
We can't explain
No,
that.
it's increasing, Sindel.
The slope is increasing.
Yeah, I already knew that.
That's what I said.
Oh, I caught your mistake.
Wow.
Yeah.
That
No,
was
you-
my mistake.
Oh, let's go.
11 over 7.
That's fine.
Slope
you did-
increasing because
Concave up.
concave up. You just match the definitions. Increasing, why? Because of that. All right. What about from -1 to 1?
Yeah, that was
It's slow.
From -1 to 1, the slope is up, but it's starting to go down, so the slope is decreasing.
Because concave up. Yes, I'll write that down.
Because concave up.
Wait, what'd you say?
You said-
Concave down.
Yeah, it's kind of down actually.
You guys are so funny. All right, what about between 1 and 2?
The next one's the same.
Between 1 and 2, the slope was down, but it's trying to go back up. It's trying to go back up. The slope is slope increasing. Y,
Because
then
we know-
concave.
Yeah.
Alright.
Oh, no.
Alright, and I think after
That's
this,
it.
yeah, we're almost done. Example 4, and we'll be done with the notes. Alright,
We need a calculator.
it says a calculator, so let's, break out those calculators. You guys ready for this?
Oh, that's so cool.
201, 204,
I'm 202.
203, 202. Here we go. Oh, well, watch Mr. Sindel. He's gonna open up his calculator too. Stand back. Put my calculator over here on the left.
Oh my god, then.
Oh,
You're ready.
Oh,
remove the ads by going pro. Thanks.
Oh
You
my
went
god,
pro?
you should still go pro.
I'm a
Oh,
pro.
Starbucks rewards? Make
All right.
rewards for
This
coffee.
video brought to you by
Free
Starbucks Rewards. All right. So, okay, T is between 0 and 3. That's what that says right there. The number of cars in a parking lot at time T hours can be modeled by some function. Cars is equal to, holy moly, that thing. Okay.
Yep.
Based on this model, at what time T does the number of cars in the parking lot change from increasing to decreasing?
I don't like this.
So we'll just graph it right here. So go to the y equals button. Top left, the y equal to button. You guys see this?
Yes.
Hover over this y1 function, and then we'll hit clear. So y1 is now a nice blank empty slate.
Oh, wait, how'd you do it?
Y1 at the top and press clear.
Top left, hit the y equal to.
Okay.
Okay, let's type this in. Remember, there's a difference between a negative and a minus sign. The negative is to the left of the enter. You're gonna write all that equation. And mark 2 set go.
Oh my goodness.
Wait, oh, here it is. I'm just gonna do X. To the power of 5. How do you do power 5?
The caret symbol is above the divided by key. It's that little.
Okay, that's what I thought. I wasn't sure. Oh my god, this didn't work.
This is so sad. I got rid of it.
No.
Thank you. 2, 1, 8.
All right, well, I think I might have to make that a little bit bigger. Okay. I have my equation typed in here. It's beautiful. How's yours? Is yours as beautiful as mine?
I messed up.
It's
What's,
beautiful.
Oh my goodness.
Mine's beautiful. Yeah, I'm gonna
Okay, here's how you graph on this calculator.
be. Okay.
I should wait until Angela's done catching up.
Yes,
I'm
all
not
men.
close.
I'm done.
Oh, I figured out how to put T.
I just
To
put
the right
X.
of the alpha, right?
Wait, what?
Just put X.
Put X. Okay, so
You got it.
what we all want to do is you guys see this this window button. Select the window button because our window is from where to where?
Window? Oh, there it is.
Our window, it tells us in our problem, our
It's
window is
from
between
0
0 and 3, so our x min is 0. So let's go ahead and clear you. Our x min is 0, and our x max is 3. Okay,
Right? Oh my god.
so make sure you have this ready to go. And you're not there? Why not?
I don't know.
I clicked on window to get here.
Okay.
It's from 0 to 3,
How
so
come
far so
yours
good.
looks like,
because I bought a calculator for free. That's my free calculator.
no, like it looks better because I have all these decimal points and crap.
I don't know.
Yeah, they should just let us.
And now we want to graph it. The way that you graph it and zoom to the correct interval is you click on zoom, and then you can scroll down if you're a simpleton. You can scroll down, but the cooler way is just to hit 0. So you don't have to go down here. Zoom 0 does zoom to fit on those X.
That did, oh, it did work. What the
So
heck?
zoom 0 and boom.
Wait, mine
That
just
is
says
not what I got.
That means you entered
Mine
in your
just goes
equation
down
incorrectly
a
if you
little
hit Y.
Wait, where's Sim 0?
Why change your T?
Yeah. That's what I said. You don't need it.
I mean, you can use it to use. Why
Oh,
does it
you
not?
just messed up my thing. You can just do undo.
Mine's already
No,
messed up.
You did it. So.
Oh my God, Saul.
Oh, wait.
Wait, you did a negative sign here, it needs to be, or you did a minus sign, it needs to be a negative sign.
That's pretty bad. I'm not gonna tell you.
He's on mic.
I was wondering if you made up
one word, something inappropriate.
Water. He just said something pretty inappropriate in class about a couch. In his free time on a couch.
Oh my God, no.
We'll sit off camera. All right, so
Yeah.
cool. We get this picture, yeah?
What are you doing if you're
So right now, I'm asking, where does the number of cars, the heights on this graph represent the number of cars? You guys can see, I'm increasing. Do you have the right graph?
No, she
Did you
just
hit-
has a home.
Did you hit zoom 0?
No, it's
Yes,
like a
I
brand.
did.
It's a Roland.
I put zoom 0. I put zoom and then like 0.
That's always backwards.
Wait. This is power of 4. Power
No.
of 4 minus 0.257x squared. Zoom 0 again. Oh, wait, there. Okay, look, this function is going, it's increasing.
Oh,
Y'all see this?
God.
Did you get this graph? Look, this graph is increasing, 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 and then all of a sudden, it's decreasing. What is the value of that point?
Oh,
You got 0.4.
We can calculate it. I will show you on the calculator how to actually find that. Ready, set. You're going to go and click on second so that we can hit this blue calculate. So it's going to be second
Second.
trace.
Second trace.
Second
Calculate.
trace to calculate. What do we want to calculate? What do we want to find here?
Minimum.
Intersection.
Intersection.
Yeah.
I want to find that place where I went from up to down. What is that called?
dy over dx.
Yes.
It's called a maximum.
Yeah.
What?
So just type in 4. We're trying to find a maximum. Then it says, okay,
Wait, mine just has a point in the middle of nowhere.
point in the middle of nowhere.
It's like in the
Yes,
middle.
okay. It's asking you, where do I want my left boundary? Do you see where it's prompting you? Where is
Yeah.
your left boundary?
Sure.
What we want to do is use our arrow keys so that we're to the
Yeah.
left of the maximum. So I'm just going to hit enter because that's to the left of the maximum. And then it's asked me, where's my right boundary? And I'm going to use my arrow key to go to the right, or if you want to be cool like Mr. Sindel and not just use arrow keys to move to the right, what I'm going to do is I'm just going to type in a value like 3,
Oh, there's enter.
enter.
Wait, what?
And bada bing, bada boom, I got it.
I literally could not find enter.
Enter's the bottom right.
I know, I see that now. I'm gonna where's what was the other thing you did?
Mine doesn't have anything on it.
I'm just kidding.
You're actually
I
expecting
did
to
this.
use these? That's
Yeah,
funny.
your maximum is that
What
x
did you
equals
do
2.44 and the height is 31.89. It tells you
You
where it happens and what the value is.
Or-
Yes.
No, why did you start a line?
You're still
Because he
looking
said
for the
it was
left
enter.
boundary. Okay, your left boundary is right there. Your right boundary is right there, and our guess is right there.
No, it's not.
It says, hey, the maximum happens at 2.445 with a height of 31.897. You all have it over here?
Oh no. I'm going like that.
Okay, that's the left boundary. I'm gonna go to the right, and the right boundary right there. It says, where's your guess? My guess is right there. And then it says, hey, the maximum happens at x is equal to 2.445, and the height is 31.897.
So that's the answer?
That's the answer. All right, so, oh yeah, so you got the boundaries, and then you want to guess right there, you hit enter, that's our guess. It says, oh, that is at 2.445, and the height is 31.897. So we need to write this down in our notes. We say, in here, at what time t? Well, that happens at time t is equal to
Oh my god, I found a 79 in the answer.
2.446,
Check it. Beautiful.
if I'm rounding.
You're rounding or not rounding?
You always round to 3 decimal places for all AP classes.
I put all over this one.
All right, everyone got 2.446?
No.
All right.
Yes,
found-
it is.
I
I
found
got 2.445.
the 79 in the Y.
But if you round that 5 up because it's followed by
I
a
just
500.
clicked something and now it's different. That's what
It's
All right.
I used to have it.
Oh my God.
So that does conclude our notes. Again, these notes, we're trying to make sure that you knew how to find rates of change for polynomials. You now know how to graph polynomials with the graphing calculator, how to find a maximum, and it's implied that you know how to find a minimum with the calculator. We know how to find leading coefficients, degrees, local minimums, local maximums, et cetera, et cetera. What we're working on now is worksheet A, topic 1.4, on this guy.
So have you heard about Charlie and the Couch?
Oh my god.
This worksheet is 5 pages long.
Are you-
Couch.
Really?
If we do not finish in class, then we finish for homework.
Oh wait, this is not. Can you send my extra?
Oh.